3, Session 4. This one is called Present Purchase. I'm going to go over our homework pages from yesterday before we begin. So we had bakery bundles. So Rachel owns a bakery and sells cookies by the dozen. She sold 16 dozen cookies on Monday. How many cookies did Rachel sell? Show your work. 192 cookies is what you should have. For number 2, for each dozen cookies, Rachel uses 1.5 cups of milk. How many cups of milk did she use for 16 dozen cookies? Show your work. 24 cups. So 1.5 times 16 equals 24. And so there's your answer. Number 3, a customer ordered 28 cupcakes. What are all the different rectangular arrangements Rachel could use to package the cupcakes? Use labeled sketches to show the possible arrangements below. So you could do 1 row of 28, 28 rows of 1, 2 rows of 14 or 14 rows of 2, 4 rows of 7 or 7 rows of 4. And then you may list only 3 rectangles, one version with each set of dimensions, or all 6, it says. And then for number 4, Rachel's assistant says that 3/5 cup of oil is more than 2/3 cup of oil. Is he correct? Explain. No, he is not, because 3/5 equals 9/15 and 2/3 equals 10/15. And 9/15 is less than 10/15, so 3/5 is less than 2/3. All right, on the next page, Rachel uses 4/5 cup of cocoa for her brownies. Write 2 fractions that are equivalent to 4/5. 8/10, 40/50, 80/100, and others, okay? A large order of 240 cookies was placed. How many cookies would go in each box if Rachel put them all in different numbers of boxes listed below? Show your work. For 24 boxes, it would be 10 cookies per box. For 12 boxes, it would be 20 cookies per box. And for 6 boxes, it would be 40 cookies per box. And then the challenge. Rachel had 1/4 gallon of milk left in her bakery. She needed to make 4 desserts for an order that afternoon. Use the table to help Rachel decide which dessert she can make 4 of with the milk that she has left. Use equations, labeled sketches, or words to prove that your choice will work. Okay. So banana pie, 8 fluid ounces. So there are 16 cups in a gallon and 8 ounces in a cup. So Rachel has 4 cups, or 4 times 8, which is 32 ounces of milk. So she can make 4 banana pies, and there isn't enough milk to make 4 recipes of any other things. All right, so in this lesson, Unit 6, Module 3, Session 4, Present Purchase, today we're going to open with a problem string designed to help you connect division, fractions, and decimals. We will solve single-step problems involving division with remainders. We will solve multi-step story problems involving whole numbers using addition and division. We will divide 2 or 3-digit numbers by a 1-digit number. And we will write fractions with denominator 10 in a decimal notation. We will reason abstractly and quantitatively. Okay. So for the problem string, the goal of today's problem string is to emphasize the connection between division fractions and decimals in the context of sharing money. So we're going to be wanting to think about money today in our lesson and our problem string a little bit here, okay? So this work will help you in solving the problems that appear in the Present Purchase student book pages that follow, okay? So I want you to get out a fresh piece of paper, or you can turn to a fresh page in your student workbook or your journal. And I want you to write today's date at the top, and I want you to title it Division, Fractions, and Decimal Problem String. And I'll give you a little bit of time to get that ready to go, and then we'll start. All right, so you should have a fresh piece of paper, whether it's notebook paper or paper in your workbook, whatever you choose to use. Or you could even, well, yeah, fresh paper. All right, here we go. The first problem is, if 5 kids were to share $5, how much would each kid get? Okay, so as I'm looking at this problem, I'm automatically thinking it's pretty easy, okay? Again, if I have 5 kids, and if they were to share $5, how much would each kid get? We're starting off easy here, okay? I'm going to flip the slide in just a tiny bit here, so see if you can figure that one out. Okay, so here we go. If 5 kids were to share $5, how much would each kid get? So basically $5 divided by 5 kids equals $1. So there's a couple different ways to look at it. You can look at it this way right here, or this is actually the same thing, or this, okay? So this one problem didn't take much to figure it out, right? Okay, so here's the next problem. What if 10 kids were to share $5? How much would each kid get then? All right, so I'll give you a little bit of time to think about that one. 10 kids were to share $5. And then I will turn the slide. Okay, so if you had $5, I think I switched that around, sorry, 10 kids, $5. $5 divided by 10 kids, each kid would get about 50 cents, right? And here's a couple different ways that you could look at it. These all mean the same thing though, okay? So this one's trickier because there are more kids than dollars, right? And the dollars would have to be split up. So twice as many people means half the amount of money, okay? All right, here's the next problem. What if 10 kids were to share $4? How much would each kid get then? So 10 kids, $4. Think about that one. 10 kids, $4. Okay, so what if 10 kids were to share $4? How much would each kid get? Well, if there was one kid and we were dividing that, you would basically go up by 25 cents, and then you see 10 cents, and then you see 5 cents times 5 cents right there. So $4 basically divided by 10 is 40 cents. 50 divided by 10 is 5 cents. $1 divided by 10 is 10 cents. You can see $2.50 divided by 10 would be 25 cents. So some of you may have thought to divide the $4 by chunks, giving each of the 10 kids a quarter, then a dime, and then a nickel for a total of 40 cents each. Okay. Here's the next, okay. And then here's another way you could look at it. So what if 10 kids were to share $4? How much would each kid get? So $4 divided by 10, that's 40 cents. So you might have just thought about it this way, which might have been a little bit easier for you. So others may reason that $4 is the same as 400 cents, and 400 divided by 10 is 40 cents per kid. So a couple different ways you can think about that one. Here is our next problem. What if 10 kids were to share $8? How much would each kid get? 10 kids, $8. Okay, so what if 10 kids were to share $8? How much would each kid get? $8 divided by 10 is 80 cents, okay? So you probably used the results of the previous problem to solve this one, meaning that they would get twice as much when they shared $4, right? Because now they're sharing $8, which is twice as much as 4, so they're going to get 80 cents, okay? All right, here's the next one. What if 10 kids were to share $2? How much would each kid get? 10 kids sharing $2. All right, $2 divided by 10 equals 20 cents. Okay, you could also think of that as 200 cents divided by 10 equals 20 cents, right? So some of you probably thought of halves of the result of the $4 divided by 10 to get 20 cents per kid. So here's some division, fractions, and decimals that we've kind of gone over here. So $5 divided by 10 would be 5/10, or 0.5, or 50 hundredths. $4 divided by 10 would be 4/10, or 40 hundredths, right? $8 divided by 10 would be 8/10, or 80 hundredths, all equal, right? And then $2 divided by 10 would be 2/10, or 2/10, or 20 hundredths. So just think about the connections that you may notice between the problems and the answers. And notice that they can use the fact that, or we can use the fact that 10 dimes make a whole dollar to help us solve division problems about money as well, okay? All right, so I have 2 more problems for you. What if 10 kids were to share $3? How much would each kid get then? 10 kids, $3. $10 kids, $3. All right, well, if we have $3 divided by 10 kids, we're going to have 30 cents. Because $3, right, is the same as 300 cents. And 300 cents divided by 10 would be 30 cents. All right, what if 10 kids were to share $1? How much would each kid get then? 10 kids, $1. Ooh. $1 divided by 10 equals 10 cents. Okay, so that, my friends, was an easy one, just like the first one, right? Okay, so now what I want you to do is use the information that we just used in that problem string to help us with these problems here, okay? So I'm going to do the first page with you, and then I'm going to have you do the rest on your own, okay? All right, so in these problems, we will determine the share of money each of the students needs to contribute in order to buy and wrap a present for their teacher. The problems on these following pages are similar to those on the string that we just completed, and each situation involves dividing amounts of money. So here's the first one. Joanna and 7 friends wanted to buy a hardcover book for their teacher from the latest book order. If the book cost $12, how much would each of the 8 friends need to give in order to buy the present? So let's just imagine here. So if each kid gives $1, that's $8. Okay, and 8 times $1, that's $8. Then 12 minus 8 equals $4. So if each friend gives 50 cents more, that's $4 more. So 8 times $1 plus 8 times 50 cents equals $8 plus $4, which equals $12. So, boys and girls, each kid needs to give $1.50 in order to pay for the book for their teacher. So there's our answer. All right, number 2. Another 8 students overheard Joanna's conversation and wanted to participate in the gift giving as well. So if 16 students wanted to buy the hardcover book, how much would each need to give? Okay, so in problem 1, there were 8 kids, and they each had to give $1.50. So now we have 16 kids, which is double 8, so 16 kids is double 8. So you have to cut $1.50 in half for this one. So $1.50 is 6 quarters, and half of 6 is 3 quarters. And I know that 3 quarters equals 75 cents. Okay, so each kid needs to give 75 cents. And I'm going to do one more with you. Number 3. The 16 students decided they wanted to purchase the book's sequel as well, which cost another $12. So how much would each kid need to give to buy $24 in books. Okay, so if we have $24, we have $12, $6, $3, $1.50. Okay, so if one were $1.50, two would be $3, four would be $6, 8 would be $12, and 16 would be $24. $24 divided by 16 equals $1.50. Now, if you think about it, it's kind of linked to this one in a way. These two problems are very similar. And then when you think about number 2, you basically halved your answer, but then you had to double it again to get your new answer. So they're kind of linked together. So be careful of those kind of problems when they do that to you. Okay, what I want you to do is student book page 244. So it says, after math discussion, the group decided that Joanna and her original 7 friends would purchase one book and the other group would get a different gift. If Joanna's group purchased plain wrapping paper, it would cost $1.60. How much additional money would the 8 friends each need to give to buy the wrapping paper? So you're basically doing $1.60 divided by those 8 people, right? Then for number 5, one friend mentioned that she saw glitter wrapping paper for $3.20. If the 8 friends chose this paper, how much would they each spend? Okay. And then finally, Joanna would also get ribbons and bows to decorate the package. If the total cost for wrapping and decorating was $6.40, how much would each of the 8 friends spend? Excuse me. Sorry, boys and girls. All right, and then student book page 245, this is simply a fraction review. So you're going to change the following fractions to mixed numbers. So the first one says 15/4. So essentially what you want to do is, that's 15 divided by 4. 4 goes into 15 3 whole times, right? 4 times 3 is 12. And 15 minus 12 is 3. So that would be my remainder is 3, which then is my numerator, and my 4 is my denominator. My denominator does not change. So I have 3 3/4, okay? That's how you do number 1, A, B, C, and D. For number 2, change the following mixed numbers to fractions. We have 3 1/4. How many fourths is that? All right, well, remember, when you have 3 1/4, remember when I talked about this in the classroom where we were changing them into improper fractions. We take the denominator times the whole number, so 4 times 3, that's 12, and then we add the numerator, so 4 times 3 is 12, plus 1 equals 13. So my answer is 13/4. Okay, so there's that one. And then for number 3, we want to write an equivalent fraction. So I'm doing the first one for each of you, obviously, and then you're going to do 2B, 2C, and 2D, in case I didn't say that, sorry. Number 3, write an equivalent fraction for each of the following. If I have 2/100ths, well, 2 divided by 1, or 2 divided by 2 is 1, sorry, and 100 divided by 2 is 50, so 1/50th is equivalent. You might also say 2/100ths is the same as 4 200ths. That works too, okay? There's multiple correct answers there. And then you're going to do B, C, and D. And then for number 4, compare the following fractions. Fill in the blank with greater than, less than, or equal to. So we have 7/6 and we have 6/7. Well, 7/6 is the same thing as 1 1/6, okay? And then we have 6/7. Well, on this side, we have more than 1 already, so there is our answer. You will do B, C, and D for me, okay? And then you have 2 more things to do. You will do Home Connection book page 127 and Home Connection book page 128, boys and girls. And that is your work for today, all right? Have a great day, have a great weekend, and I will see you soon. Keep working hard. Whoopsies.